Welcome back. It's time to implement all that we've learned in the previous videos and make a functional programming paradigmed Amazon shopping cart. So let's think about this. We want to implement a cart feature. That is, we want to add items to cart, add a 3% tax to the item in the cart, and well, we want to buy an item, which means moving whatever's in the cart to the purchases of the user. And then we finally want to empty that cart. So it looks like all of these are functions that we're going to need to do. What are these functions? Let's just list them out so that we have a good plan in place. We want to obviously purchase item, which is going to do all of that for us. So the first thing is I'm going to have a function purchase item. What else? Well, we want to add items to cart. So I'm going to create another function, items or item to cart. Let's keep it on a single line right now because we don't have anything. What else? Well, we want to add tax. So I'm going to create another function, call it apply tax to items. We have function buy item, which will physically move the cart to purchases. And then finally, we'll do the empty cart. So function empty cart. All right, so we have our function that's going to affect the data that we have, that is the user. Now, based on what I learned about functional programming, I want to keep these pure. But it also looks like I'm applying a bunch of steps to the same data. Maybe we can use something like compose to compose all these steps so that purchase item does, well, all these things over here. So the first thing I want to do is, well, just to test out that everything is working, let's just create the naive approach where we return from purchase item. Let's say we receive the user and the item from here. So we're going to receive this user and the item, and we're going to return the user with the new item. So let's just say we want to return, well, we know that we want to keep things immutable. We don't want to just modify the user. So I'm going to return a new object. I'm going to use object.assign here. And object.assign, we can create a new object using an empty object that we're creating as a first parameter, then the actual object that we're copying over, and then we're going to add any updates to that object as a third parameter. So I'm going to say that the third parameter is going to be the fact that, well, I want the purchases to be added to the item. So I'm going to say purchases is going to include the item. So nice and easy, naive approach. So that if I call purchase items here, or purchase item, and I give it, let's say name is laptop, and the price is $344, nice and cheap laptop. If I run this, and I get object assign is not a function because not spelling correct, assign, GN. That's better. Let's run this. Hey, look at that. I get something back, but something's not working. And that's because, remember, I have two parameters here, and I need to pass the user into purchase items. So let's add the user in here and hit run. And there you go. Kim, which is an active user, now has purchased laptop that costs $344, and it's in their purchases history. That's great. But that's not what we needed to do, right? We have to do all these things because, well, people can't just buy things. They have to add things to their cart. We have to apply the taxes. We need a record of what happened. And we don't know what Kim did. Maybe she wants to remove things from the cart. This is too simplistic. And looking at this, I'm thinking we need compose. We need to compose these functions together. I've changed my mind. I don't want to do this anymore. This is too simplistic. What I want to do instead is something like this. I want to be able to compose purchase item. I want to be able to add item to cart. And you know what? Let's rename this to add item to cart because it makes more sense. I want to add the item to cart initially. And then because we're using compose, we're going to go from left or right to left. So we want to add the item to cart. Then we want to apply tax to the items in the cart. And then we also want to, well, buy the item. And then finally, once we've done all of that, then we can empty the cart. All right. Let's add commas here so that I don't get a syntax error. And I want to be able to do this. I have a factory called purchase item that takes data, which will be the user and the item. So that is the name. That is laptop with a price of laptop just went up in price. It's way more expensive. Actually, you know what? Let's keep it cheap, 200. And I want to be able to do this. I want to give this data to this function, then this function, then this function, then this function, and I want all of this to happen for me. All right, so it looks like we need compose. So let's compose these functions together. The very first thing is, well, let's create a compose function. I'm going to say const compose. That's going to receive function ng. So that's the first two parameters. But we have a problem here, right? Because we now have more than two functions that we want to go through. What can we do here? Now, this is part of the reason that you'd use a library like Ramda or Lodash to use compose, because you don't need to implement it yourself. I'm going to show you the way to do it, but keep in mind that it does look a little confusing. I prefer using the library version usually because, well, it hides away a lot of the complexity. But in this case, we have way more arguments. So I'm going to use the spread operator to get all of the other arguments. And then in here, I'm going to call f over g. And inside, just spread the arguments. So I have compose now. I also want to define purchase item. And this purchase item, actually we have it over here, so let's come down here. This purchase item, we're going to change things up a bit here. The purchase item is going to receive what? Well, it's going to receive a bunch of functions, right? And we don't necessarily know how many. So I'm going to just spread these functions. And these spread functions are going to, well, return what? I want to use these functions and I want to be able to compose them. So what I'm going to do is I'm going to use reduce. And if you're not sure what reduce is, make sure you check out the video that I linked to with advanced arrays. And in reduce, I'm going to pass a callback function that will take a previous value and the current value, or an accumulator and the next value. So if I pass compose here, the reduce function, which is in itself a higher order function, is going to run this for me, which is going to take f and g, but it's also going to iterate through empty cart, buy item, tax to items, add items to cart, and actually return one by one and run these functions. Like I said, this can be a little overwhelming at first. You might have to spend a few minutes figuring out what exactly you're doing. But essentially, we've built our own compose function that allows us to enter any number of parameters that we want into the purchase item so that we can compose these functions and act over the data that we receive. All right, so let's go step by step now and see what we can do. The first thing I want to do is add item to cart. So with add item to cart, it's going to receive a user and the item. And in here, we're going to just create a simple function. We want to add a updated cart. And this updated cart, well, we want to add to the user's cart. But we don't know what the user had previously. We want to make sure that we don't mutate any of the previous arrays. We want to return what we currently have. Let's do this instead. We're going to say user.cart.concat, which will add a new array that is completely different and copied from the previous array or the original array. And in here, I'm going to pass the item that we're buying so that we can finally return object.assign. And in here, we return a new object, once again, user, with a new cart item. All right, in order to see that this works, let's, from all these other functions, you see that I'm returning a new user state. So in all these functions, I'm going to have a user, and it's going to, well, let's just return user from each of these functions. So as the data funnels through, we can see the output. So I'm not doing anything in these functions other than, well, passing the data through. Let's see if I've made any typos here. If I run this, purchase items. Oh, and this is not an error function. This is a function declaration. So I have to make sure that I return in here this properly. If I run this, hey, look at that. Kim now has an item in her cart. How cool is that? I was able to purchase items. Well, I was able to do the first thing, add item to cart. And I passed on the data to the next functions that we're composing, but they just received the user and just passed it all the way out, like a factory. How cool is that? All right, now that we've created this, this is a pure function, just takes in something and returns something. No matter how many times we call it, it's always going to be the same. Let's apply all the other functionality to these ones as well. The first is to apply tags. I'm going to say const, and let's use this structuring here so we don't have to do user.cart all the time. So let's say user. And in here, let's just say that the tax rate is 1.3. Did I say 3 or 30%? 3% tax, okay. So let's create const tax rate. And this tax rate will be 1.03. You know what, let's do 30% for now, just because we can see the difference a lot better that way. So 30% tax, that's a big tax. And we're going to say updated cart is going to equal cart.map. Remember, cart is an array. We're going to map over this. And we're going to map over each item. And we're going to return a new object that contains, well, the name. That is the item.name. So nothing's changed there, but the price is going to be different. It's going to be item.price multiply by the tax rate. So that finally, at the end of it all, we can just return object.assign. Remember, we want to return the user, but a new copy of the user with the updated information that has the cart, updated cart. So that if I run this, hey, look at that. The price of the laptop went up because we applied the tax to it. It went from 200 to 260. Oh boy, this tax is really killing us. All right, let's keep going with buy item. So in here, we want to move the cart item to the purchases. Again, using our functional approach, this should be an easy one. All we need to do is object.assign. And in here, we have an empty object. the user that we receive, and all we do is, well, we have the purchases, and we update that with the items in the cart. So it'll be user.cart. If I run this, oh, and once again, I'm not spelling object.assign properly. Let's try that again. Hey, look at that. We have our purchases, but we need to remove this from the actual cart because now Kim has purchased her laptop. So with our last function, to finish things off, let's do the last piece, object.assign. Hopefully I'm spelling that right this time around. We have an empty object that we attach the user to, and then we update the cart to be what? Just an empty array. If I run this, holy moly, Kim has just purchased her first laptop. It was $260 because of the big tax, but hey, now she can do all the coding that she wants. How nice was that? I mean, it was a little bit complicated at first because we had to create this compose function. But now that we have this compose in place, this purchase items works really nicely, right? Exactly like a factory where we add item to cart, apply tax to items, buy item, empty cart. If a new functionality, such as upgrade Kim's status to not active, if we needed to add new functionality, the rest of the code doesn't really care about that. We can just create a new function and just add it in here. That's the beauty of functional programming. This idea that we're building these small composable functions that are each worried about their own world, so that whenever bugs happen, well, as long as they're tested well, it's most likely not them. It's most likely in a place where we might have state or we might be mutating state, but we will know that, hey, these functions are okay because they're pure. Now, here's the really, really interesting part and why I think functional programming and the concepts around it are so interesting. Because now, if we want to say, create another function like refund item, well, again, that's easy to do. We just have to remove things from purchases or even from the cart. But the more interesting thing is the idea of now being able to play back history. Because let's be honest, if you were Amazon, you want to keep track of your data. You want to know what users did. Maybe Kim complains that, hey, I purchased my laptop, but it's not in my purchases. I didn't receive it. And Amazon needs a way to go back in time and figure out what happened. They need logs of what the user might have done that may have resulted in an error on their side. Inadvertently, using our functional programming paradigm, we have an ability to travel back and forth through time. Let me show you. If, for example, we have a database, let's just say const database, or you know what, let's do history. Let's do Amazon history. And this will be, well, actually initially will just be an empty array. And every time we do something, we want to add to this history. For example, in the add item to cart at the beginning, I can just say amazon.history.push the current user state. And then maybe I want to make sure that I capture the state of the user before we applied the taxes. Maybe here when we buy the item, and then empty cart. I'm just pushing this user data to our Amazon history so that when I run Amazon history and I click run, check that out. I have the entire history of Kim and what she did. Now, this doesn't look very pretty right now, but I hope you can see that we have Kim initially with no purchases, nothing in the cart, and all the way till the end where she has purchases. And right now, she still has the things in the cart because we haven't captured the history after we empty the cart. But we can go back in time now. As an Amazon employee, I can go back in time and see where Kim made her purchases, when she added things to the cart, when we added taxes to the items. Now, behind the scenes, maybe Amazon can create new functions like get user state, or function that is go back in history, or go forward. How cool is that? Another thing that you might be asking yourself is, whoa, how come we're doing push in Amazon history? Isn't that state? Aren't we modifying state? And remember, we can't just purely have pure functions. In order for us to do anything with a program, at some point we do have to mutate data. The idea of functional programming is to minimize those mutations. All right, this video is getting long, so I want to finish off with the idea of pipe. Remember, compose is we go from right to left. How would we fix this with pipe? Well, if you prefer reading left to right, we just change this compose to pipe and just change G into F and F into G. We'll have to change the orders of these around into the opposite direction, but that's it. You can choose pipe or compose based on what you like. All right, that's enough talking for me. I hope that was exciting for you. We're able to use all that we've learned in the previous videos to implement something quite clean. Now, this is obviously a simple example, but I hope you now see the power of functional programming. I'll see you in the next one. Bye-bye.